A cylindrical tank contains an unknown amount of water. If water is added to the tank at a rate of 5 liters per minute for 12 minutes, the volume of the water will be 89 liters. In part A, we are asked to write an equation for the volume of the tank as a function of time. We will also draw the graph. The question tells us that after 12 minutes, there is 89 liters of water in the tank. Therefore, the point 1289 exists on the graph. Plot the point 1289. Also, we know that the tank is being filled at a rate of 5 liters per minute. This is the slope of the line. Let's store the rate so we can reference it later. Since we have the slope and a point on the line, let's get the equation using slope-point form. Start with y minus y1 equals m times x minus x1. Plug in x1, y1, and m. Distribute 5 through the brackets. Simplify the equation. We need to write this as a function. The dependent variable is the volume of water, which is on the y-axis. The independent variable is time, which is on the x-axis. The function is v of t equals 5t plus 29. v of t equals 5t plus 29 has the same form as y equals mx plus b. Therefore, the v-intercept occurs at the ordered pair 0, 29. Plot this point. Let's look at the tank. The question specifies that it initially contains an unknown amount of water. Comparing the tank with the graph, we can now see that the initial amount of water is 29 liters. As we fill the tank at a rate of 5 liters per minute, notice that the graph will pass through the point 1289. Moving on to part B, what is the volume of water in the tank after 17 minutes? We can use the function v of t equals 5t plus 29 to find the volume of the water after 17 minutes. Rewrite the function. We want to find the volume of water after 17 minutes. Plug in 17 for t. Evaluate the right side to get 114. The volume of water in the tank after 17 minutes is 114 liters. We can find this on the graph at the point 17, 114. Now we'll move on to part C. The maximum volume of the tank is 134 liters. How long can the tank be filled before it overflows? We know the volume of the tank is 134 liters and we need to find the time. Rewrite the function. Replace the left side with the volume of 134 liters. Subtract 29 from both sides to get 105 equals 5t. Divide each side by 5 to isolate t. The value of t is 21. The tank will overflow after 21 minutes. We can find this on the graph at the point 21, 134.